Right, this is number 8, 9, and 10 from the review, so 3 solving systems of equations. So this first problem is a simple substitution problem because we got that x by itself. That means we're going to take what it's equal to and substitute it in for that same variable in the second equation. So we're plugging in 2y minus 3 for the x in the second equation. So I'm going to write out the second equation and I'm going to leave space where I see the x because that's where I'm going to do my substitution. I use parentheses, so where I plug in the value that's equal to x is where the 2y minus 3 goes. From there, I just have to distribute, and then before I solve, I need to combine like terms, and then add 9 to both sides and divide by 5. So we get y is equal to negative 3. In order to completely solve a system, though, we need both x and y. So when we go back, we can plug it back into that first equation. X is equal to 2 times y, but we now know that y is equal to negative 3. And then, of course, minus 3 comes after that. So follow order of operations, negative 6 minus 3 gives us negative 9 for x. Make sure that we write x first and y second, so our solution is negative 9, negative 3. Number 9 is an elimination problem. If we look vertically, both of our equations are in standard form, and it's looking like eliminating y's is going to be easier because I already have 4 and 8, so I only need to change that first equation. Because I already have a positive 8y, I know I want a negative 8y, so I'm going to multiply that first equation by negative 2. Let's go ahead and distribute it to all 3 terms. 2x minus 8y equals positive 40. Now that we have a positive 8y and a negative 8y, we can add to eliminate. And then solve. Now all we have to do is plug that 8 back into one of our original 2 equations. I'm plugging it into the first one, and then simplify and solve. We get y is equal to negative 3. And again, we have to write our answer as an ordered pair. X comes first, y comes second, and then we're done. Number 10 is a substitution problem, once again because we have that isolated variable. So this time we're going to be plugging in 2x plus 1 for y in the second equation. So here's my substitution step. As soon as I see the y, I'm going to put in parentheses and keep on continuing. Once I finish writing the equation, I plug in what y is equal to. Go ahead and distribute. And we get 4x plus 2 equals 4x plus 2. And that looks like something weird's going on, but I'm going to keep going. I'm going to subtract 4x from both sides just to be sure. I get the statement 2 is equal to 2, which is most definitely true. Therefore, we have infinitely many solutions. Remember, that is not the same as all real numbers. Not all numbers will work for x and y, but an infinite number of xy combos.